Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. All right, let's get right to it. Today we're going to learn how to solve systems of equations, of linear equations that is, by graphing. And systems of equations, whether they be linear or not, are basically a set of two or more simultaneous equations. They can be both linear equations or nonlinear. Today we're going to be talking about and learning about how to solve systems of linear equations by graphing. A linear system consists of two or more specific linear equations. The solution of any linear system is the ordered pair xy that makes both equations true. So if you go ahead and think you have a solution to a system, go ahead and check yourself. Plug that ordered pair into both equations that were given. If both of them render true solutions, then that is indeed the answer or the solution of the system. For example, if we go ahead and graph y equals 1/2 x plus 5, let's just go back in time real quick. Remember, you always want to graph the y-intercept first. So that's 1, 2, 3, 4, 5. Right here's my y-intercept. Then I'm going to follow the slope both forwards and backwards. So remember, it's a rise over run when positive, and when slope is negative, it's a fall over run, always reading from left to right. So I'm going to literally go up 1 over 1, 2 to the right, up 1 over 1, 2 to the right, backwards, down 1 over 1, 2 to the left, down 1 over 1, 2 to the left. That's going to be my blue graph here. Let's go ahead and change colors to green now. For my second graph in this system, y-intercept here is 3, so that's 1, 2, 3. My slope this time is -1/2, so I'm going to fall down 1 over 1, 2 to the right, down 1 over 1, 2 to the right. To go backwards, I'm going to go up 1, 1, 2 to the left, up 1, 1, 2 to the left. You probably noticed that right here is where both equations intersected, and that is the solution of this system. If I were to plug in this solution into either of the equations given, let's see if it would work. Does 4, which is the y value, equal 1/2 of x, which is -2 plus 5? Well, that's going to be -1 plus 5, which does equal 4. So that definitely works for the first equation. How about for the second one? If y, which is 4, does that equal -1/2 times x, which is -2 plus 3? And that's going to be 1 plus 3, which is 4. So once again, yes, that works. All right, let's try it on your own. Let's go ahead and solve this system of linear equations by graphing. If you remember, in order to graph any type of linear equations, you want to first make sure that you have the given equation in standard form, which would be, slope-intercept form, which would be y equals mx plus b. So let's get that y alone. So let's start by adding 3x to both sides. So I have y equals 3x plus 8. And I'm going to divide by 2. Remember that when you're dividing to both sides of the equation, please make sure that you divide that value to everything on the opposite side. This is my first equation there, here in black. Let's go ahead and make this guy in blue. I'm going to subtract the x to start with. Now I'm going to divide by 2 to every single term on the other side. And y is going to equal -1/2 x minus 4. So let's go ahead and graph this first one. Y-intercept is 1, 2, 3, 4. Slope is up 1, 2, 3, 1, 2 to the right, 1, 2, 3, 1, 2 to the right, backwards, down 1, 2, 3, 1, 2 to the left, down 1, 2, 3, 1, 2 to the left. Connect those dots, and we have my first line there. And my second blue line, y-intercept is -4, down 1, 2, 3, 4. Slope is -1/2, down 1, 2 to the right, down 1, 2 to the right, backwards, up 1, 2 to the left, up 1, 2 to the left, up 1, 2 to the left. And you probably already caught where the intersection was, which was right there at 1, 2, 3, 4, -2. So -4, -2 is the solution. And once again, if you plug them back into the original equations, they will work. All right. Let's try another one. If I were you, I would hit pause right now and try this on your own. So go ahead and hit pause and try on your own. Welcome back. Let's see what you got. Okay, for this first graph, which I'll go ahead and graph in blue this time, I subtracted the x and I divided by that -2y, so that's going to render me with y equals +1/2 x minus 2. The second equation we'll go ahead and label in red. We're going to simply subtract the 3x to both sides, giving me -3x plus 5. Let's go ahead and graph each. Blue first. Y-intercept is -2. Slope is 1/2, so I'm going to go up 1, 2 to the right, up 1, 2 to the right, up 1, 2 to the right, backwards, down 1, 2 to the left, down 1, to the left, down 1, to the left. And we have our line here. And our second line here in red, y-intercept is 5. 1, 2, 3, 4, 5. My slope is -3. So I'm going to go down 1, 2, 3, 1 to the right. Down 1, 2, 3, 1 to the right. Bingo, there it is. Down 1, 2, 3, 1 to the right. I always like to go at least one further after I found my intersection. So that way I can have a really nice, complete graph. And here in purple, that's my intersection, that's my solution. My solution point is at 2, -1. And once again, if I went ahead and plugged that ordered pair into either of these equations, it will be true. All right, great. Now, sometimes we can be savvy and figure out how many solutions a system of linear equations has without even graphing them. And we can find that out by slopes. So for example, all systems of linear equations are either going to have one, what's called a consistent system, where you have at least one solution. What does that mean? If you have intersecting lines, you're going to have one solution, one intersection. Okay? When you have one solution of intersecting lines, that is called consistent, independent, because you have one individual solution. When you graph the same line on top of itself, that's what's called coinciding lines. And coinciding lines, since they are the same exact line, they have infinitely many solutions. And this is what's called a consistent dependent, because each line depends on itself because it is itself. All right. And then you can also have what's called an inconsistent solution. And an inconsistent solution occurs when you have parallel lines. Parallel lines have no solutions. They are inconsistent because they never intersect. So it's pretty simple. So how can we tell here by slopes? Okay, it's easy to tell by graphs, but how we tell by slopes was real simple. If you have a consistent, independent system, that means that your slopes are always going to be different. Period. If you have different slopes, you're going to have one solution. They're going to intersect somewhere. If you have coinciding lines, that means that the lines are the same. That means that the slopes are equal and also the y-intercepts are equal. So coinciding lines are lines that have the exact same slope and the exact same y-intercept. They're the same exact line. And you can tell by simply looking at a system of equations, by looking at just the equations, if it's an inconsistent system, because no solutions occur when the slopes are equal and the y-intercepts are different. And that's what happens there. So let's check it out. All right, without graphing, is the system independent, dependent, or consistent? Well, let's check it out. Solve for y, first things first. So, okay, let's go ahead and, like this guy here, solve for y. I'm going to add the 2x, divide by 4. So y is going to be 1/2 x plus 3/2 after simplifying and reducing to lowest terms. Second equation, I'm going to divide everything by 8 here. So y is going to equal 1/2 x minus 3/2. Well, in this particular case, if you notice, the slopes are equal, but the y-intercepts are not. So let's check out which one of these three categories it falls in. If the slopes are the same with different y-intercepts, then the lines are parallel, and therefore there is no solution. Well, here in this particular case, the slopes are equal, the y-intercepts are different, so this is a no solution. This is an inconsistent system. Let's look at the blue. If the slopes and the y-intercepts are the same, then the lines are the same, and therefore you have infinitely many solutions, and that would be consistent dependent. And in green here, if the slopes are different, not equal, then the lines are independent, and there is one solution, consistent independent. Let's try on our own. Without graphing, the system is the system independent, dependent, or inconsistent? Let's check it out. Let's first solve for y here by adding over that 3x. And then here, I'm going to subtract the x and then multiply by a -3, right? Just in case you don't see that. If you remember, you can get rid of the denominator anytime when you're solving by simply multiplying that denominator to every single value on both sides of the equation. Then we divide by that -1. So y equals 3x plus 3. In this case, once again here, we have the same slopes of 3, different y-intercepts. So this would actually be no solution. This would be inconsistent. And last but not least, without graphing, is the system independent, dependent, or inconsistent? Let's go ahead and solve for y here. Subtract the 2x, divide by 3. You're going to have y is equal to -2/3 x plus 1/3. And when we solve for this one, I'm going to subtract 4x to both sides. So that's -4x minus 3. In this case, we have different slopes. So when you have different slopes, that means automatically it's an independent situation. There's one solution. So this is independent. Consistent, independent. And there you are. Hope you learned a lot. Thank you, and come back anytime. Have a great day.